with that, let me open this up and see where I am. Uh, yeah, okay, good. I'm still in test stand. Okay. All right, so let me use the remainder of our short remaining time, 15 minutes, playing with the ChatGPT. This is what I've been doing, and one of the reasons I split up the timed assessment demo between last week and this week is so that I could do a portion of the problem set still. So let me do that. I have problem set 9 open here. Let me, yeah, 10 questions. Let me open ChatGPT on the side, and this time the way I'm gonna be using it, it's an honest use of ChatGPT. By the way, I can't do it with O1. It disappeared today. They must just upgraded it to O3. So I'll just use O3. I can't continue to use O1. It's just gone. I guess O3, O1 must have used too much responses, which actually leaves me in a bit of a difficult spot. As I'm writing the lecture comprehension questions, I really like O1's styles better than O3, but I'll deal with that later this week. I'll see if O3 still writes questions that I feel are substantial enough. Because before what was available was O3 mini high. So with the O3 maybe it'll still go into the depths that I want it to. So because I'm not using ChatGPT to cheat, I'm really trying to use it to learn. I do need to give it this prompt. I mean, let me demonstrate. If you don't give it this prompt, if you simply give it a question, it'll just answer the question for you, even if you don't, tell it to help me cheat. I'm not. I'm trying to avoid doing any work. Even if you don't tell it that, it's been trained to answer all the questions as fully as possible. So unless you give it a contrary instruction, tell it, I don't want the thing that most human beings prefer. I actually want to learn. I actually want to do the work. Unless you do that, it'll do this. It just gave me these answers, which I can just check off by reading the first few words, and then it'll. Oh wow, it's not fully correct. Oh, wonder if we can. Um. So let me give it a try. Okay, it looks like it's mostly correct, but you missed something. Can you fix it? This could be actually a good demonstration of the kind of the benefit of having something that's interactive. Because if it was just let's say a solution manual that has this mistake, then you're kind of done. What else do you do? Did I just check it off wrong? You know what? I checked it off wrong. It said it decreases, and I checked this. Um, I wonder if it'll spot that I simply checked it wrong. Um, oh yeah, 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 yeah. It's an operator error, not ChatGPT error. Yeah. Oops. Oops. Yeah. Right. So, anyways, but don't do this. Really, at the moment when you are doing it, you might even, read the ChatGPT responses, and you might even think you understood it. But I will tell you from experience that a lot of times when you read something that's technically dense for the first time, you will think you understood it. And then later on, you will discover, oh, I either didn't understand it or I understood it at such a shallow level that I didn't retain any of it later. Like if you come back to this question, 6 hours later or a day later, can you still, starting from scratch, can you check the correct ones? Maybe, maybe not. So you really have to give ChatGPT this instruction so that it won't answer all the questions right away. It'll just help you work through it. So I'll say also I'm working through this problem set to help me prepare for the upcoming one-on-one meeting with my instructor, and he will expect me to be able to work through these questions without any outside help. Can you please help me learn by not giving me answers right away? Help me work through step by step whatever I'm stuck for the time, please. And it'll acknowledge, and then we'll continue from there. So we only have like less than 10 minutes, so let's just pick one question that I think could be challenging, and we'll just do that. All these are, you can just look up the formulas. It's, look up the Stefan Boltzmann law and that ratio. Can I do this in my head? Yeah, it's, I think, factor of 6. So 6 raised to the power of 4 is 36 times 36. I don't think I can do that in my head. Uh, well, so 6 times 36 is 216. So I think that's a 12, 9, 6, maybe. Yeah. Again, easy questions. Um, this, yeah, this is actually one of the things difficulties I'll have in the one-on-one meeting. A lot of the questions here are easy. Once you have the correct formula, you can just answer it quickly. There might be a harder question towards the end, maybe. Even Compton effect, once you have the Compton formula, is easy. But I can imagine doing this. Maybe actually this was me, because I think my lower division classes didn't cover special relativity and quantum mechanics all that thoroughly. So I think I basically entered university upper division without knowing what Compton effect is. And when I first encountered it, I didn't realize there's a formula derived in the textbook that takes relativity into account, all that. I was just, working through it for myself. Okay, momentum is conserved, energy is conserved, and I was first working it out non-relativistically. So, for energy conservation, you say, um, let me move this so that there's enough space. For energy conservation, you say that, okay, you got the photon energy coming in, that's your incident energy. So energy of the photon, initial, no prime, is equal to your final energy, which would be energy of the photon primed plus 1/2 mv squared for the electron. And electron, yeah. And then I use momentum conservation. So I say, okay, photon momentum. I think I knew enough to say photon momentum is photon energy divided by C. That's equal to, and here I am careful, photon is going to be bouncing back. So I say minus E gamma prime divided by C. Oops, that is actually, oh no, that is final. Yeah. So for the momentum, then I'm saying plus MVE. And should I say gamma MV? Let's work out VE and see if that might be greater than C. If it's less than C, then so now if you work it out this way, you will get the wrong answer. But let me imagine someone who's doing that, and let me imagine that someone doing this more quickly. So I think you can do this with Wolfram alpha. You got how many unknowns? Magnitude. That's actually harder. Let's do part B. Yeah, because this particular difference, it's the kind of thing where Compton formula makes it super easy, but doing it here makes it harder. But if I do this, then I can say basically from knowing the incident wavelength, I know E gamma. So I can treat E gamma prime as unknown, VE as unknown, solve for that. So I can solve E gamma. E gamma is equal to E gamma prime plus 0.5 times m times v squared, and E gamma is equal to minus E gamma. Yeah, I'm setting C equal to 1. Prime plus m times v for V and E gamma prime. Can you do that? Let me see if Wolfram Alpha will understand and do that correctly. Let me see if ChatGPT will do it correctly. You might not. I don't know. If neither of them will do it, I can do it by hand. No, the instruction I gave it is now interfering. So, I'll just do it by hand. I can actually do linear combination. So if I'm using C is equal to 1 unit, I can just say, all right, I don't care about that. I can imagine simply adding them. E gamma prime cancels out. So I get this quadratic equation of 2E gamma is equal to, let me write it here, is equal to 1/2 MVE squared plus MVE. In fact, this Wolfram Alpha probably can do. So I can say solve. Instead of system of equations, a single equation, 2 times E gamma is equal to 1/2 times M times, I'll say X squared plus M times X for X. Well, it might need a number. So for E gamma, let's just plug in the numbers. It's gonna be the so energy of a photon is its Planck constant times frequency, and frequency in terms of wavelength is speed of light divided by wavelength. H over lambda, yeah. So that's gonna be my E gamma. So I can say for E, let's just work out those numbers. So Planck constant times speed of light divided by 0.01 nanometer in electron volts. So I have 0.124 mega electron volts, and I'll keep everything in mega electron volt units. So 0.124 mega electron volts. The electron rest energy is, I happen to have this memorized, 0.511 mega electron volt, or electron rest energy, 0.511 mega electron volt. X squared, and this is still 0. And the answer we get for X, V will be, it's going to be complicated, I think. So I think VE will be in, so if this is MeV units, I think this has to be in, if C is equal to 1, maybe VE will just come out in the unitless beta specification. So X, the root, let's say we are looking at positive root, approximate forms 0.403. Okay, maybe. So let's say we got V is equal to 0.4038 C, and you say maximum percent change in photon wavelength. So from here you let me wrap this up. So what I need to is I need to work out E gamma prime, and I think I can do that easiest from here. So from here, E gamma prime is, move that over, move this over, MV minus E gamma. And I'm gonna keep everything in the same units I've been using. So let me put this down here, up here. So MV is gonna be the 0.511 mega electron volt, V 0.4038, minus the 2 times, I thought I worked out E gamma before. I think it's 0.124. That was E gamma. So yeah, 2 times 0.124. Um, yeah, so I think that's where you do run into an issue. You get a negative answer um, for the final. Um, so I'll say is negative. That's an issue. Um, so let's say I think I'm sufficiently stuck to look for help from ChatGPT. Um, so, all right, different question. I think I'm stuck on this collision question. Can you help me? I get nonsensical results. And it's been hit or miss how much of my work ChatGPT figures out. So I can imagine it just giving me the what would be the really the most efficient advice? You should be telling me, oh, there's a formula for Compton effect. Use that. Don't redo the whole thing because it's gonna take a lot of work. That's what it should tell me. And but I would also like it to figure out that I've been using non-relativistic expressions, and that's the reason for these nonsensical results. And let me see if it does that. It might not. Um, Symbolic expression, um, photon energy and momentum. Okay, electron rest mass. Yeah. Okay. Um, so let's say yeah, I did it here. So I don't think it's interpreted my work yet, but once I pasted it in, then it'll do a better job of looking at what I did. And at that step, it should figure out, those are non-relativistic expressions used, yeah, and non-relative kinetic energy. So let's say as you look at it, then you figure out, oh, yeah, okay. Oh, I need to use relativity, but this is in quantum mechanics chapter. I don't think that this question is meant to be so difficult. I wonder if from that it can help me figure out that there's a Compton formula that you can use. And that's what I would recommend when you are doing this homework. I mean, you going through the whole relativistic derivation, it can be instructive. And it'll take you 10 times the amount of time it'll take just using the Compton formula. And so let's see, let me look at the response to, yeah, it's interesting. Yeah. Um, yeah, it's still giving me the long derivation. Um, Well, I'll say I prefer the second one. I don't know. I think they are both kind of not what I was looking for. Uh, uh, so this isn't what I recommend, but let's see how well ChatGPT does. If I just ask it for, is there a textbook formula? That still looks like more steps than I expected to do. We use OpenStax University Physics Volume 3. Is there a formula in the textbook I can look up which will help with the question. And by the way, so during the one-on-one meeting, you can use the textbook. So whatever formulas are derived in the textbook, you don't have to be able to rederive them. As long as you know where to find them and you know how to use them correctly, then great. Then that's what's required for the one-on-one meeting. That's frankly one of my dissatisfaction about how easy these questions are. So yeah, you could do this. And I think this is another question. In that once you have the right formula to use, it's super easy. It's not that hard. But if you're trying to do the derivation from scratch, like that could be the entire 1 hour meeting. So, so yeah, yeah, ah, I think that's it. And I can use the textbook during the meeting. So as long as I know how to use the textbook formula, I'll be fine. Thank you. So I'll just leave that there. And we are already way over time. So as soon as ChatGPT is done, thank you so much to those of you joining this meeting to the end, both those who may be joining by recorded video and those who are here in real time. Let me say goodbye to people joining by recorded video, and I'll stay online briefly in case people who are here in real time had any questions they wanted to ask of the recording. So bye to people joining by recorded video.